You stand on the edge of a vast, rust-colored desert, the air thin and cold, a faint howl of wind brushing past your suit. Mars stretches before you, its crimson dunes rolling under a butterscotch sky. You squint toward the horizon, where jagged peaks claw at the heavens, and far beyond, the polar ice caps gleam like forgotten diamonds. Could something ancient, something alive, be hidden beneath that frozen veil? The question burns in your mind. Did Mars once harbor life, maybe even a civilization, now locked away under layers of ice? You're not alone in wondering. Scientists, dreamers, and explorers have been chasing this mystery for centuries. Welcome to the Martian enigma, where every grain of dust might whisper secrets of a lost world. Let's start with the basics. Mars, the fourth planet from the Sun, is a world of extremes. Its towering volcanoes, like Olympus Mons, dwarf anything on Earth, and its canyons, like Valle Marineris, could swallow entire mountain ranges. But it's the ice caps at the planet's poles that draw your gaze. These shimmering expanses, made of frozen water and carbon dioxide, hold clues that could rewrite our understanding of life in the cosmos. You imagine standing on one, the ice crunching under your boots, the faint glow of reflected sunlight casting eerie shadows. What's beneath? Frozen microbes? Fossilized remains? Or, dare you think it, the ruins of something far grander? The idea of life on Mars isn't new. Back in the late 19th century, astronomer Percival Lowell peered through his telescope and swore he saw canals crisscrossing the planet's surface. He spun tales of a dying Martian civilization, desperately channeling water to survive. Sure, his canals turned out to be optical illusions, but his passion ignited a spark. You can't help but chuckle. Lowell's wild imagination was like something out of a sci-fi novel, yet it pushed humanity to look closer. Today, we know Mars isn't the lush oasis Lowell dreamed of, but it's not the barren wasteland we once thought either. The planet's history is a puzzle, and the pieces are scattered beneath its surface. Here's where it gets juicy. Mars wasn't always this cold, dusty relic. Billions of years ago, it might have been a cosmic Eden. Evidence suggests liquid water once flowed in rivers and pooled in lakes, maybe even oceans. You picture yourself standing by one of those ancient shores, the water lapping gently, a faint breeze carrying the scent of wet stone. Could life have taken root here? Scientists think so. On Earth, wherever there's water, there's life. Bacteria thriving in scalding vents or beneath Antarctic ice. Mars ice caps, layered like a cosmic cake, might preserve traces of that primordial soup. But here's a quirky twist. Some researchers believe these ice caps could hide cryovolcanoes, volcanoes that spew ice instead of lava. Imagine that. A mountain burping frozen slush onto the Martian surface. Now, let's push the boundaries. What if life on Mars wasn't just microscopic? What if long ago intelligent beings walked its surface, built structures, and left their mark? You pause, letting the idea sink in. It's a stretch, sure, but not impossible. The ice caps could be a time capsule, locking away evidence of a civilization that thrived before Mars turned hostile. Some scientists argue we should look for technosignatures, unnatural patterns or structures that scream someone was here. Others counter that we're chasing shadows, that any life would likely be simple microbes. This debate, technosignatures versus biosignatures, sits at the heart of the Martian enigma. Which side are you on? Are you ready to believe in Martian cities, or do you lean toward humble bacteria? You turn your gaze back to the ice caps. They're not just pretty. They're a scientific goldmine. Radar scans from orbiters like NASA's Mars Reconnaissance Orbiter have revealed vast deposits of water ice, some buried just meters below the surface. You imagine a drill piercing the frost, pulling up samples that could hold organic molecules or fossilized cells. The thought sends a shiver down your spine, and not just from the Martian cold. Every mission to Mars, from Viking in the 1970s to Perseverance today, has been a step toward answering this question. Yet, the planet guards its secrets well. It's like Mars is playing a cosmic game of hide-and-seek, and we're still learning the rules. Let's lighten things up for a second. If Martians did exist, do you think they'd have thrown interplanetary barbecues? Picture little green chefs grilling under a double-moon sky, Phobos and Deimos cheering them on. Okay, maybe not. But the idea of life on Mars, simple or complex, keeps us hooked. It's not just about finding aliens. It's about understanding our own place in the universe. If life arose on Mars, it means the cosmos might be teeming with it. You, standing on this alien world, are part of a bigger story, one that stretches across stars and eons. Before we dive deeper, let's pause. What do you think lies beneath Mars' ice? Ancient microbes? A lost city? Or just more rocks? Drop your thoughts in the comments. We're dying to hear your theories. As you ponder, consider this. Every discovery on Mars brings us closer to answering one of humanity's oldest questions. You're about to take a journey through time, from a warm, wet Mars to the frozen world we see today. The ice caps are calling, and they've got stories to tell. Ready to listen? You're floating above Mars, the planet's ochre surface sprawling beneath you, carved with ancient scars that tell a story billions of years old. Once, this wasn't a frozen desert. You imagine rivers snaking across the plains, their waters glinting under a younger, bluer sky. Lakes shimmer in the distance, cradled by rugged cliffs. And maybe, just maybe, something alive stirs in their depths. Mars, long ago, was a world that could have been home. You're here to uncover its ancient past, to ask, was this red planet once a cradle for life? Picture Mars 3.5 billion years ago. The air is thicker, the temperature milder, and liquid water flows freely. You can almost feel the damp soil under your boots, smell the faint tang of minerals carried by a breeze. Scientists call this the Noachian period, a time when Mars looked more like Earth than the barren world you see today. Evidence is everywhere. Dried riverbeds, like the ones in Gale Crater where Curiosity rovers tread, snake through the landscape. Ancient lake beds, etched into places like Jezero Crater, hint at standing water that lasted for millennia. You imagine dipping your hand into one of those lakes, the water cool and clear. Could microbes have thrived here, clinging to rocks or floating in the currents? Let's ground this in reality. NASA's rovers have found clay minerals, smectites to be precise, that form only in the presence of liquid water. These aren't just random rocks. They're time capsules from a wetter Mars. You picture them, layered in the soil, holding secrets of a world that once was. The planet's magnetic field, now long gone, was active back then, shielding the surface from harsh solar radiation. Volcanoes, like those in the Tharsis region, belched gases that thickened the atmosphere, creating a greenhouse effect. It's not hard to imagine life taking hold in such a place. On Earth, microbes flourish in the harshest environments. Think of the extremophiles in Yellowstone's hot springs. Mars, in its youth, wasn't so different. Now, here's a fun fact to make you smile. Some scientists think Mars might have had hot springs too. Imagine Martian microbes throwing a tiny spa party, bubbling away in geothermal pools. Silly, sure, but it underscores a key point. Life doesn't need a perfect paradise to thrive. It just needs the right ingredients: water, energy, and a few key chemicals. Mars had all three. In 1976, the Viking landers scooped up Martian soil and ran experiments to detect life. One test, the labeled release experiment, got a positive result: chemicals suggesting metabolic activity. Scientists still argue over whether it was life or just weird chemistry. You feel the tension in that debate, don't you? Was it a false alarm, or did we brush against something alive? Here's a quirky detail you might not know. Mars' ancient water wasn't always pure. Some of it was likely salty, maybe even acidic, based on minerals like jarosite found by rovers. Picture a Martian lake, its surface rippling with briny waves, hostile to most life, but perfect for tough microbes. These extreme conditions mirror places on Earth, like the Rio Tinto in Spain, where bacteria thrive in acidic rivers. If life existed on Mars, it might have been a gritty survivor, not unlike those earthly microbes. You can almost see them. Tiny specks of resilience, clinging to existence in a world growing colder and drier. The academic debate here is fierce. Some researchers argue Mars' habitable phase was too short, maybe a few 100 million years, for complex life to evolve. Others counter that life could have emerged quickly, as it did on Earth, where simple organisms appeared within 1 billion years of the planet's formation. You stand at this crossroads, wondering, was Mars' window of habitability long enough for life to take root? Or was it just a fleeting chance? The answer lies buried in the planet's past, and every new discovery pulls you closer to it. As Mars aged, catastrophe struck. Its magnetic field weakened, leaving the atmosphere vulnerable. Solar winds stripped away the air, and the water either froze or evaporated into space. You picture the planet's transformation, its rivers drying, its lakes turning to dust. Yet, some water survived, locked in the polar ice caps or hidden underground. These remnants are your lifeline to the past. If life existed, it might have retreated to these refuges, leaving traces for you to find. Orbiters have spotted signs of subsurface lakes, radar echoes suggesting liquid water beneath the South Pole. You imagine plunging into one, the darkness swallowing you, the weight of ancient ice pressing down. Let's lighten the mood for a moment. If Martians did exist back then, do you think they'd have built sandcastles by their lakes? Okay, probably not. But the image of a Martian beach day makes you grin. The real question is more profound. If life arose on Mars, what does it mean for the universe? A second Genesis, right next door, would suggest life is common, maybe even inevitable. You feel the weight of that idea, the way it expands your view of the cosmos. As you gaze across this ancient Martian landscape, the past feels alive. The rocks, the craters, the faint traces of water. They're all whispering stories. You're not just exploring a planet. You're chasing a possibility that could change everything. The question lingers. Did life once call this place home? And if it did, could its echoes still be waiting, frozen in time, for you to uncover? You hover above Mars' South Pole, where a vast expanse of ice stretches like a frozen ocean under a rusty sky. The polar cap glows faintly, its layers of water ice and carbon dioxide stacked like pages in a cosmic book. Each layer holds secrets, traces of ancient climates, perhaps even life itself. You imagine running your gloved hand across the frost, feeling its brittle chill. What lies beneath this icy vault? Could it hide evidence of microbes or something stranger, locked away for billions of years? You're about to dive into the Martian ice caps, where the planet's deepest mysteries are frozen in time. These ice caps are more than just pretty scenery. They're Mars' memory, preserving a record of its past. The North Cap, called Planum Boreum, spans 1,000 kilometers, while the South Cap, Planum Australe, is smaller but no less intriguing. Both are layered like geological lasagna, with ice and dust stacked over millions of years. You picture yourself drilling into one, the whir of the machine echoing in the thin air, each core sample a snapshot of Mars' history. Scientists estimate these caps hold enough water to cover the planet in an ocean 11 meters deep if melted. That's a lot of water, enough to make you wonder what swam in it long ago. Let's back up to a historical milestone. In 2008, NASA's Phoenix lander touched down near the North Pole and confirmed water ice just centimeters below the surface. You can almost see the lander's robotic arms scooping reddish soil, revealing a gleaming patch of frost. It was a game changer, proving Mars still holds water in solid form. But here's the kicker. The ice caps aren't just water. They're laced with carbon dioxide ice, dry ice, that sublimates into gas during Mars' summer, creating wispy clouds and seasonal changes. You imagine standing there, watching the cap shrink as the dry ice hisses into the atmosphere. It's like Mars is breathing, isn't it? Now, for a quirky tidbit. Some of the South Pole's ice sits atop weird, spider-like formations called arenae-forms. These are channels carved by escaping gas, looking like cosmic creepy crawlies etched into the surface. Picture them, sprawling beneath the ice, as if Mars is doodling its own alien artwork. These oddities hint at dynamic processes, jets of gas erupting, reshaping the terrain. Could similar processes have trapped organic molecules or microbial fossils in the ice? You feel the excitement of that possibility, like a detective chasing a lead. The ice caps are a treasure trove for astrobiologists. On Earth, ice preserves life remarkably well. Think of Ötzi, the 300-year-old Iceman found in the Alps, his body intact down to his tattoos. If Mars hosted life, its ice caps could be a deep freezer for ancient microbes. You imagine finding a fossilized cell, its delicate structure preserved in a crystalline tomb. Radar data from orbiters like Mars Express has revealed something even wilder. Liquid water lakes beneath the South Pole's ice, detected by strong radio echoes. You picture a dark, briny lake, hidden under kilometers of frost, where life might still cling in suspended animation. But here's where the debate heats up. Some scientists argue these subglacial lakes are too salty or cold to support life as we know it. Others say extremophiles, those tough-as-nails microbes from Earth's harshest corners, could handle it. You're caught in the middle of this academic tug-of-war. Are these lakes sterile? Or could they harbor dormant life? The question pulses like a heartbeat. If life exists, the ice caps are the best place to look. They've shielded organic material from Mars's harsh radiation, which fries the surface like a cosmic microwave. You imagine a future mission, a drill piercing the ice, pulling up samples that could rewrite textbooks. Let's lighten the mood for a second. If Martians had ice caps back in the day, do you think they'd have gone ice skating? Picture a gang of aliens gliding across Planum Boreum, maybe even playing Martian hockey with a rock. Okay, probably not. But it's fun to dream. The real magic is in the science. Instruments like SHARAD on the Mars Reconnaissance Orbiter map the ice's internal structure, revealing layers that shift with ancient climate changes. Each layer is a clue, like tree rings, telling stories of wetter times or massive dust storms. The ice caps also hint at Mars' wild climate swings. Unlike Earth's stable tilt, Mars wobbles on its axis, causing dramatic shifts in its seasons over millennia. You picture the caps growing and shrinking, locking away dust and ice like a time machine. Some layers might contain volcanic ash or meteorite debris, others perhaps the chemical fingerprints of life, methane, amino acids, or lipids. You feel the weight of discovery, the possibility that a single sample could confirm we're not alone. Every mission to the poles, from orbiters to future landers, brings you closer to that moment. As you gaze across the icy expanse, the silence is profound, broken only by the faint whistle of Martian wind. The ice caps are more than frozen water. They're a gateway to the past. You're standing on the edge of a mystery, one that could reveal life's ancient presence or even the echoes of a lost civilization. The frost glitters, beckoning you deeper. What secrets are waiting, just below the surface, ready to change everything you thought you knew? You're trudging across a Martian plain, your boots kicking up clouds of reddish dust that swirl like ghosts in the thin air. The landscape is littered with rocks, jagged, weathered, and ancient. You squint at one, its odd shape catching your eye. Is it just a rock, sculpted by eons of wind, or something more? A fossil? A fragment of some long-lost structure? Your heart races at the thought. Mars is a graveyard of mysteries, and every stone might hold a clue to life, or even a civilization, buried in its past. You're here to sift through the dust, chasing the tantalizing question: are we looking at fossils, ruins, or just the planet's cruel tricks? Let's start with the ground beneath your feet. Mars' surface is a geologist's dream, scarred with craters, canyons, and strange formations that whisper of a dynamic past. You kneel beside a rock in Jezero Crater, where NASA's Perseverance rover has been poking around. Its layered texture looks suspiciously like stromatolites, those earthly mounds built by ancient microbes. You can almost feel the rough surface, imagining tiny organisms stacking minerals billions of years ago. On Earth, stromatolites date back 3.5 billion years, some of the oldest evidence of life. Could Mars have similar relics? The rover's instruments have sniffed out organic molecules, carbon-based compounds that are life's building blocks. You picture them, locked in the rock, waiting for a microscope to reveal their secrets. But it's not just about microbes. Your mind leaps to wilder possibilities. What if those angular shapes in satellite images aren't natural? You've seen the infamous face on Mars from 1976 Viking orbiter photos, a hill in Cydonia that looked eerily human. Scientists later chalked it up to pareidolia, our brain's knack for seeing patterns like faces in clouds. You chuckle, thinking of Mars as the ultimate Rorschach test, teasing us with ambiguous shapes. Still, the idea lingers. Could some formations be artificial? A crumbled wall, perhaps, or a tool carved by intelligent hands? You imagine stumbling across a stone block, too perfectly shaped to be natural, its edges worn but deliberate. Here's a historical nod. In 1877, Italian astronomer Giovanni Schiaparelli mapped Mars and described canali, Italian for channels, which got mistranslated as canals, sparking fevered dreams of alien engineering. Those dreams fizzled, but they fueled a century of exploration. Today's high-res images from orbiters like Mars Reconnaissance Orbiter show no canals, but they do reveal oddities. Hexagonal patterns, possible mud volcanoes, and mineral veins that scream, "Something happened here." You feel the weight of those discoveries, each one a breadcrumb leading to a bigger truth. Now, for a quirky detail, some rocks on Mars, called blueberries, are tiny hematite spheres scattered across the surface. Found by the Opportunity rover in 2004, they're formed by water seeping through rock, like cosmic marbles. You picture them rolling under your boots, a playful reminder that Mars once had liquid water, maybe enough for life. These blueberries aren't fossils, but they're a clue that Mars was wet, and where there's water, life might follow. You imagine a microbial mat, fossilized in a rock, its delicate structure preserved like a snapshot from a billion years ago. The academic debate here is a fiery one. Biosignatures, chemical or physical traces of life, are the holy grail, but they're tricky to confirm. A weird rock might be a fossil, or it might just be geology doing its thing. Some scientists argue Mars' harsh surface, blasted by radiation, would destroy most organic evidence. Others point to protected niches, like the ice caps or subsurface caves, where fossils could survive. Then there's the bolder claim. What if we're not just looking for microbes, but technosignatures, signs of intelligent design? A single unnatural artifact, a carved stone, a metallic fragment, would flip our understanding of the cosmos. You're torn. Do you bet on simple life or dare to dream bigger? Let's ground this in what we know. Perseverance has been collecting rock samples, some destined for Earth via future missions. You imagine those samples under a lab microscope, revealing microscopic fossils or just maybe a hint of something crafted. Radar and spectral data have spotted anomalies, like methane spikes in the atmosphere, which could come from microbes or geological processes. You picture a faint whiff of gas rising from the soil, a clue that something's stirring below. Every finding pulls you deeper into the mystery, like a detective piecing together a case. For a moment, let's lighten things up. If Martians built anything, do you think they'd have left us a welcome sign? Maybe a neon "Martians were here" flickering in a crater? Okay, probably not. But it's fun to imagine. The real thrill is in the hunt. Every rock, every shadow, every chemical trace could be the key. You're not just exploring Mars. You're chasing a question that could redefine humanity's place in the universe. If life or intelligence once existed here, it means we're not as alone as we thought. As you stand on this dusty plain, the rocks around you feel alive with possibility. Each one could be a fossil, a ruin, or just another trick of the Martian light. You're closer than ever to answers, but the planet keeps its secrets close. The dust swirls, the horizon glows, and you can't help but wonder, what's waiting to be found? You're standing in a Martian crater, the rim rising like a silent sentinel around you. The wind whispers across the reddish soil, carrying a faint chill that makes you shiver. You look down at a peculiar stone, too angular, too precise. Is it just erosion's handiwork? Or could it be a relic of something more? Your mind races to a bold idea. What if intelligent beings once called Mars home? Their cities now buried beneath dust and ice. You're diving into the civilization hypothesis, a cosmic leap that asks whether Mars once hosted a society as complex as our own. Let's paint the scene. Billions of years ago, Mars might have been a vibrant world. Rivers flowing, skies tinged blue, perhaps even forests of alien flora swaying in a thicker atmosphere. You imagine a Martian city, its structures carved from red stone, glinting under the weak light of a distant sun. Could sentient beings have walked here, building, dreaming, maybe even stargazing at Earth? The idea feels like science fiction, but it's not pure fantasy. Scientists have long speculated about life on Mars, and while microbes are the safer bet, the possibility of intelligent life isn't entirely off the table. You feel the thrill of that thought, like standing on the edge of a cliff. The civilization hypothesis hinges on Mars' ancient habitability. We know it had liquid water, a magnetic field, and volcanic activity, conditions that could support life for millions of years. You picture a bustling ecosystem, maybe with creatures that evolved beyond simple bacteria. On Earth, intelligence emerged after billions of years of evolution, from single-celled organisms to dinosaurs to us. Mars' habitable period might have been shorter, But who's to say evolution couldn't have worked faster? You imagine a species, perhaps humanoid, perhaps utterly alien, crafting tools or raising structures. The thought sends a jolt through you. Could their ruins be waiting, frozen beneath the polar ice caps? Let's anchor this in history. In the 1960s, when Mariner 9 sent back the first detailed images of Mars, scientists were stunned by its volcanoes and canyons, hinting at a geologically active past. Those images sparked dreams of what might have been. No one's found a Martian pyramid yet, but the search for technosignatures, evidence of artificial structures or technology, has become a serious field. You chuckle, imagining a Martian archaeologist's delight. A buried city, its walls etched with strange symbols. But here's the reality. Most scientists lean toward natural explanations for Mars' odd features, like the Cydonia face or pyramid-like mounds, blaming wind and time rather than alien architects. For a quirky twist, consider this. Some researchers suggest Mars' methane spikes, detected by rovers like Curiosity, could hint at industrial activity, not just microbes. Methane can come from geological processes, but on Earth, it's also produced by factories. Picture a Martian factory, long abandoned, leaking gas into the atmosphere. It's a wild idea, but it fuels the hypothesis. You imagine a rover stumbling across a metallic fragment, its edges too smooth to be natural, sparking debates that echo across the globe. The academic argument here is a doozy. Skeptics say Mars' harsh conditions, radiation, cold, and a thinning atmosphere would have snuffed out any chance for complex life. They argue we should focus on biosignatures, like fossilized microbes, rather than chasing alien cities. But others counter that intelligence could have arisen briefly, leaving subtle traces we've yet to recognize. What counts as a technosignature? A carved stone? A chemical anomaly? You're caught in this cosmic tug-of-war, weighing the practical against the profound. If a civilization existed, the ice caps, shielded from surface radiation, are the perfect place to look. You picture a drill piercing the frost, pulling up a fragment that screams, "Made, not born." Let's explore the evidence, or lack thereof. High-resolution images from orbiters show no clear ruins, but they do reveal anomalies. Geometric patterns, possible water channels, and mineral deposits that don't quite add up. You imagine a satellite zooming in on a buried structure, its outline faint but undeniable. Rovers like Perseverance are collecting samples that might hold clues, perhaps organic compounds or unnatural isotopes. The European Space Agency's Mars Express has mapped subsurface ice, hinting at hidden cavities where artifacts could lie. You feel the anticipation, like waiting for a locked chest to open. Now for a lighter moment. If Martians had a civilization, do you think they'd have had Martian coffee shops? Picture a little alien barista serving up a steaming cup of whatever Martians drank. Silly, sure, but it humanizes the question. The search for a Martian civilization isn't just about aliens. It's about us. Our need to know if we're alone. If intelligent life arose next door, it means the universe might be buzzing with minds, each with their own stories. As you stand in this crater, the stone in your hand feels heavier. Is it a relic of wind or will? The civilization hypothesis stretches your imagination, daring you to dream big. The ice caps loom in the distance, their layers hiding answers. You're not just searching for life. You're chasing the possibility of a lost world, one that could redefine everything you believe about the cosmos. You're perched on a Martian ridge, the red dust crunching under your boots as you watch a sleek rover crawl across the plain below. Its solar panels glint in the faint sunlight, and its cameras swivel like curious eyes. Overhead, An orbiter hums silently, mapping the planet's secrets with invisible waves. You feel the pulse of modern exploration, a symphony of technology peeling back Mars' mysteries layer by layer. From rovers to radar, humanity's tools are rewriting the story of the red planet, hunting for signs of life, maybe even a civilization hidden beneath its icy surface. You're here to see how far we've come and how close we are to answers. Mars exploration has come a long way since the days of grainy telescope images. Today's tech is a marvel. Take NASA's Perseverance rover, rolling through Jezero crater with a suite of instruments that would make any sci-fi nerd jealous. Its Sherlock scanner zaps rocks with lasers to detect organic molecules, while its drill collects samples for future return to Earth. You imagine the rover's wheels grinding over the terrain, each turn kicking up dust that might hold microscopic clues. Orbiters like Mars Reconnaissance Orbiter use high-resolution cameras to snap images so sharp you could spot a coffee mug left on the surface. If Martians drank coffee, that is. Let's rewind to a historical milestone. In 1997, the Pathfinder mission landed Sojourner, the first rover to roam Mars. It was a tiny thing, barely the size of a microwave, but it proved we could explore another planet up close. You smile, picturing Sojourner as the little rover that could, paving the way for giants like Curiosity and Perseverance. Since then, technology has leaped forward. Orbiters now carry radar systems like SHARAD, which peer beneath the surface, revealing ice deposits and possible liquid water lakes. You picture those radar waves bouncing back, painting a hidden world of frost and caverns. Here's a quirky gem. Perseverance carries a tiny helicopter called Ingenuity, the first aircraft to fly on another planet. Imagine it buzzing above the Martian surface, its blades whirring in the thin air, scouting terrain like a curious dragonfly. It's not just a stunt. Ingenuity's flights have helped map hard-to-reach areas, guiding the rover to promising sites. This kind of innovation is key to the search for life. Rovers drill into rocks, spectrometers sniff for chemicals, and cameras hunt for fossil-like patterns. Every data point is a step toward answering whether Mars once hosted microbes or something more. The ice caps are where this tech shines brightest. The European Space Agency's Mars Express orbiter used its MARSIS radar to detect what might be a liquid lake beneath the South Pole's ice. You imagine standing above that lake, the ice above you glowing faintly, the water below dark and still. Could it harbor dormant microbes? Or maybe, just maybe, relics of a lost civilization? Ground-penetrating radar can map subsurface structures, spotting cavities or anomalies that might hint at artificial origins. You feel the excitement, like a treasure hunter with a high-tech map, knowing each scan could reveal something extraordinary. The academic debate here is intense. Some scientists argue that current tech, rovers, orbiters, even future drills, can only confirm simple life, like microbial fossils. Others push for bolder goals, like searching for technosignatures, unnatural shapes or materials that scream intelligent design. You're caught in the middle, wondering if a rover's camera might one day catch a glint of something unmistakably crafted. A tool, a wall, a fragment of a Martian past. The challenge is Mars' harsh surface, where radiation erases delicate evidence. That's why the ice caps are critical. They shield clues from the planet's relentless environment. Let's talk about what's next. Future missions, like NASA's planned Mars sample return, aim to bring rocks back to Earth for analysis in labs far more powerful than anything we can send to Mars. You picture scientists in clean rooms, poring over samples that might hold fossilized cells or chemical traces of life. Meanwhile, proposed missions like the Icebreaker Life Lander could drill deep into the polar caps, seeking organic molecules preserved in ice. You imagine the drills hum, the ice chips flying, each sample a potential key to the cosmos. For a light moment, let's dream. If Martians left tech behind, do you think we'd find their version of a smartphone? Picture a rover tripping over a shiny alien gadget, its screen still glowing with Martian selfies. Okay, maybe not. But the idea keeps you hooked. Technology is our bridge to Mars' past, turning dreams into data. Every mission, every scan, every sample brings you closer to the truth. You're not just watching a rover roll, you're part of a quest that could prove life, or even intelligence, once thrived next door. As you stand on this ridge, the rover below pauses, its camera zooming in on a rock. The orbiter above beams data to Earth. And you feel the weight of this moment. Mars is speaking, and our machines are listening. The ice caps, the rocks, the hidden lakes, they're all within reach. You're on the cusp of discovery, and the next signal could change everything. What will it find? A microbe? A relic? Or just more dust? The answer is out there, and technology is bringing it closer every day. You're gazing across the Martian horizon, where the polar ice caps shimmer under a salmon-colored sky. The ground beneath you vibrates faintly, as if humming with secrets yet to be uncovered. The search for life on Mars, whether microbial or something grander, has been a decades-long odyssey, and it's far from over. Each mission, each discovery, pulls you closer to the truth. But the planet remains coy, daring you to dig deeper. You're here to explore what lies ahead in humanity's quest to unlock Mars' mysteries, from new technologies to bold missions that could finally answer, was there life beneath the ice? The future of Mars exploration is electric with possibility. You imagine a sleek lander touching down near Planum, Australia, its drills poised to pierce the ice caps. NASA and other space agencies are planning ambitious missions, like the Mars Sample Return (MSR) program, a joint effort with the European Space Agency. Perseverance has already cached rock and soil samples in Jezero crater, and MSR aims to bring them back to Earth by the early 2030s. You picture scientists in sterile labs, analyzing those samples with microscopes so powerful they could spot a single fossilized cell. The thought sends a thrill through you. Those rocks could hold the first proof of extraterrestrial life. But it's not just about bringing samples home. New missions are targeting the ice caps directly. Concepts like the icebreaker, Lifelander proposed drilling meters into the polar ice, searching for organic molecules or microbial remains preserved in frozen layers. You imagine the drills whine, ice chips spiraling upward, each sample a time capsule from Mars' wetter past. Other ideas include sending advanced rovers with ground-penetrating radar to map subsurface structures, hunting for cavities or anomalies that might hint at ancient habitats, or even artificial relics. You feel the anticipation, like waiting for the final piece of a puzzle to snap into place. Let's nod to history for a moment. In 1976, the Viking landers ran the first experiments to detect life on Mars, and one, the labeled release experiment, returned puzzling results that some still argue hinted at biological activity. You smile, thinking of those plucky landers, our first boots on Martian soil, sparking debates that rage today. Fast forward to now, and our tools are light years ahead. Orbiters like Mars Express have already spotted signs of liquid water beneath the South Pole, and future missions could confirm whether these lakes are habitable. You picture a robotic probe diving into one, its lights piercing the dark, briny depths. Here's a quirky twist. Some scientists are dreaming up bio-inspired robots for Mars. Imagine a rover modeled after a mole, burrowing beneath the ice to sniff out chemical traces. These astro-biomimetic designs sound like something out of a sci-fi flick. But they could revolutionize exploration. reaching places too tough for wheels. You chuckle, picturing a robotic mole tunneling through Martian frost, popping up like a cosmic whack-a-mole. These innovations are key because the ice caps, shielded from surface radiation, are prime spots for preserving evidence of life. Whether it's a microbe's fossil or, dare we say, a fragment of something crafted. The academic debate here is a lively one. Some researchers argue we should focus on biosignatures, chemicals like methane or amino acids that suggest life. Others push for a broader search, including technosignatures, like unnatural structures or isotopic anomalies that might point to a civilization. You're caught in this cosmic crossfire. Do we double down on finding simple life, or keep an open mind for something bigger? The ice caps could settle this. Their layers, like pages in a book, might hold organic molecules or even geometric patterns hinting at artificial origins. You imagine a radar scan revealing a buried structure, its shape too perfect to be natural. Looking ahead, private companies like SpaceX are joining the fray. Elon Musk's vision of crewed missions to Mars by the 2030s could see humans walking the red planet, drilling into ice caps themselves. You picture an astronaut, suit dusted with frost, unearthing a sample that changes everything. International efforts, like China's Tianwen-2 mission, are also ramping up, planning to return samples and explore new regions. Every mission tightens the net around Mars' secrets, and you feel the momentum building, like a wave about to crash. For a lighter moment, let's dream big. If we find Martian life, do you think we'd throw a galactic party? Picture humanity toasting with Martian-themed cocktails, red, of course, celebrating our cosmic neighbors. Silly, sure, but the stakes are profound. Confirming life on Mars would mean the universe might be teeming with it, reshaping our view of existence. Even if we find nothing, the search itself drives innovation, pushing us to explore farther, dream bigger. As you stand on this Martian plain, the ice caps gleam in the distance, their secrets locked tight. New missions are coming, rovers, drills, maybe even humans. Each will probe deeper, ask bolder questions. You're part of this journey, chasing a truth that could redefine the cosmos. The search continues, and the next discovery might be the one that changes everything. What will we find beneath the ice? The answer is out there, waiting. You're floating above Mars, the red planet's rugged surface sprawling beneath you, its ice caps glinting like beacons in the dim light. The search for life, whether a humble microbe or a lost civilization, has brought you here to the edge of human understanding. Every rock, every frozen layer, whispers a question. If life existed on Mars, what does it mean for us? You're not just exploring a planet, you're peering into a mirror, reflecting humanity's place in the vast, star-strewn cosmos. Let's pause and ponder. How does this quest reshape who we are and where we're going? The idea of life on Mars hits you like a cosmic jolt. You imagine holding a Martian fossil, its delicate structure etched in stone, proof that life sparked twice in our solar system. Or maybe it's a fragment of something crafted, a tool, a carving, hinting at minds that once gazed at the same stars you do. Either way, the implications are staggering. If life arose on Mars, it suggests the universe is a fertile garden, not a barren void. You feel the weight of that possibility, like standing on a cliff overlooking an endless sea of stars. It's humbling, exhilarating, and a little terrifying all at once. Let's ground this in a historical touchstone. In 1609, Galileo turned his telescope skyward, revealing a universe far grander than anyone imagined. His observations of Jupiter's moons shattered the idea that Earth was the center of everything. You smile, picturing Galileo squinting through his crude lenses, unaware he was kickstarting a revolution. Mars is our modern Galileo moment. Finding life here would do more than rewrite textbooks. It would shift our perspective, making us feel both smaller and more connected to the cosmos. You imagine humanity pausing, looking up, realizing we're part of something vast. Now for a quirky twist. Some scientists speculate that Martian life, if it exists, might share a common origin with Earth's, carried by meteorites billions of years ago. Picture a cosmic delivery service, microbes hitching a ride on space rocks between planets. It's called panspermia, and it means you might be distant cousins with a Martian bacterium. You chuckle at the thought, your family tree stretching across the solar system. But it's more than a fun idea. If life on Mars is related to us, it narrows the search for our origins. If it's unique, it opens the door to countless other worlds teeming with life. The academic debate here is profound. Some argue that finding Martian life would confirm that biology is a universal rule, like gravity or thermodynamics. Others caution that a lifeless Mars could mean Earth is a cosmic fluke, a lonely oasis. You're caught in this philosophical tug-of-war. Is life common, or are we the exception? The ice caps hold the key. Their frozen layers might preserve organic molecules, fossils, or even technosignatures. Clues to a civilization that could mirror our own ambitions and fears. You imagine a future discovery, a single sample that rewrites our story, making you feel both insignificant and boundless. This quest isn't just about Mars, it's about us. Every rover, every orbiter, every planned mission reflects humanity's curiosity, our drive to push beyond the horizon. You picture the engineers building Perseverance, the scientists poring over data, the dreamers staring at the night sky. They're all part of this journey, and so are you. The search for Martian life fuels innovation. New tech, new ideas, new ways to explore. Even if we find nothing, the act of looking changes us, making us bolder, more collaborative, more aware of our fragile place in the universe. Let's lighten things up for a moment. If we find Martians, do you think they'd approve of our sci-fi movies? Picture an alien critic binging The Martian, giving it 2 tentacles up for effort. Silly, sure, but it reminds you why this matters. Mars is our neighbor, a world we can touch, explore, maybe one day walk on. The possibility of life there makes the universe feel less lonely, like finding a friend in a crowd of strangers. You imagine humanity celebrating that discovery, not just with science, but with art, stories, and dreams of what's next. As you float above Mars, the planet's surface seems to pulse with possibility. The ice caps, the craters, the dusty plains, they're all part of a bigger story. One you're writing with every question you ask. If life existed here, it means we're not alone. That the cosmos might be alive with voices we've yet to hear. If Mars is barren, it makes Earth's life all the more precious, a spark to protect. Either way, this search shapes you, urging you to look up, to wonder, to keep exploring. You're not just a speck in the universe, you're a seeker, chasing truths that could echo across the stars.